we are describing pairs of angles, dealing with complementary and supplementary and linear pair and vertical angles. The essential question we have, how can you describe angle pair relationships and use these to find angle measures? In your student journal, I want you to work with your groupies right now and go ahead and work through the exploration on page 27. We're going to do that one as well as the exploration on page 28. We're going to spend a couple minutes on that. All right? Off you go. Page 27 and 28, exploration, 1 and 2. Hey, five-pointed star has a regular pentagon at its center. What do you notice about the following angles? X and Y, Z and Y, and X and Z. Okay, what about X and Y? Yeah?
They add up to 180 degrees.
They add up to 180. How do you know that?
Because they are both on a straight line.
They're on a straight line. Okay. So we have X and Y adding up to 180 because they are on a straight line. So this plus this make a straight line. Okay? Y and Z. No one else? Dude. Same thing as this one? Yeah. Yeah, they're on a straight line. Okay? How about X and Z? Yeah, X and Z look like they're congruent, right? Okay, so this angle right here and this angle right here, they look congruent. How do they look congruent? Well, they're kind of the same thing. In math, did anyone know what we call that? That is called vertical angles. Anytime you have two lines crossing, like so, they make two sets of vertical angles. You have this set right here, X and Z. Tell your neighbor another set of vertical angles there. Okay, volunteer. Another set of vertical angles. Isaac. Yeah, Y and 108. Okay, that means Y equals 108. Good. Okay, find the value of the indicated variables. Well, we know Y. Y is 108 degrees. That's a big degree symbol. Let's go with that. 108 degrees. How about X? 72. Yeah, it's 180 equals X plus 108, right? Which means X equals 72. Right? This and this have to make 180. How about Z? 72. How do you know Z is 72? It's congruent to X. Okay, they're vertical angles. Plus, you can use the straight angle. The straight angle things, those are called linear pairs. Tell your neighbor why they would be called linear pairs. Why would we call them a linear pair? Drew? Yeah, because they make a straight line. They're on the same line, man. Okay? Letter W. Anyone know what this one is? 72, same as Z. Remember, this is a regular pentagon. What does the word regular mean in math? Danica? Good. The word regular means all the sides are congruent. This is congruent to that, and congruent to that, and congruent to that, and congruent to that. So if all those sides are congruent, that means, when I cruise back in here, all these properties, why did that get so dark? Try this again. There we go. Nice, that would focus. A little better. Okay, if that's congruent, then this triangle right here, if I redraw it, okay, this 108 that was right here is also right here, okay, and we have a straight line, so this would be 72. That if this is 72, this one's 72. Okay, this right here is the same as that right there. That's becoming really, really messy. I'm sorry. Unbelievable. Letter V. Letter B is right here. How many angles, or how many degrees in a triangle? 180. So what is V? 36. Okay, 36 degrees. Because 72, 72, and V have to make 180 degrees. Okay. All right. So there we got it. Explain how you obtained each answer. We kind of went through that as we did. All right, any questions there? Other than why is your diagram so messy? And next time it'll be neat. Okay. Example 2, or exploration 2. Look at the partner. A square is divided by its diagonals into 4 triangles. What do you notice about the following angle pairs? Go ahead and work through that real quick. Okay, come on up, fill them in, and have your reason why, but we'll talk about those here in a minute. All right, let's check them out. So A and B are congruent. It said. Are they congruent? How many agree it's congruent? A and B. Okay. C and D, are they congruent? How about C and E? Are those congruent? What are these called? Vertical pair. Okay, those are vertical angles. So we're good there. Those are congruent. Are C and D congruent? Well, how could we prove that C and D are congruent? How could we actually know that? Jeremiah? They're on a straight line. So that's saying 90 degrees, this angle, plus C, this angle. So those two angles right there have to add up to the straight line, which would be 180. So if one's 90, the other one has to be 90. C equals 90 degrees. All right. Good? Okay. So let's go back to A and B. How can we prove that those are congruent? This is 90. It's easy to say they're congruent. How do we know they're congruent? Yeah? Okay. This one's 90, that one's 90. So this one's 90? Is that what you're saying? D is 90 as well? Okay. So how do we know that these two have to be the same still? I'll agree that that's 90. Can we show that these sides are equal? Like, is this equal to this? Yes? Everyone agree it is? Okay. And if those are equal, what type of triangle do we have? This equal and this equal. Talk about it. What type of triangles are those? Those are called, starts with an I. Yes, those are isosceles triangles, and isosceles triangles have base angles that are congruent. Therefore, if this angle is congruent to that one, and this one's congruent to that one, and this triangle is congruent to that one, these two angles are equal. Okay? So yes, these two angles are equal. All right, so measure of angle C, we have 90. Measure of angle D is 90. Measure of angle E is 90. All these are 90 degree angles in here. Okay? All right. You can do your communicating and understanding on the bottom, your answer a little later if you'd like. But right now, I want you to go to this next page, page 29. And let's talk about some of these things we've been dealing with. One is called complementary angle. What's a complementary angle? Yep. I don't know. Is it when two angles equal 180? It is? Is it 90 or 180? I mean, usually these are the two things we get messed up on. I like to think of it this way. Complementary and supplementary. They both start with those letters, right? One starts with a C, one starts with an S. And check it out. If I just add one line, I know the answer to my question. Complementary is 90. Supplementary is 180. Okay? Supplementary angles are angles, and it does not have to be two. It could be 5 angles that add up to 180. There are angles that will make 180 degrees. Complementary are angles that will add up to 90 degrees. They do not have to be the same angle. They do not have to be connected angles. Okay, they just need to be angles that add up to 90 degrees. Those are called complementary angles. Supplementary angles are angles that add up to 180. So a linear pair, is that supplementary or complementary? Remember, a linear pair lie on a line. How many degrees is a line? 180 degrees. All right. Linear pair. Those are complementary, or excuse me, supplementary angles.
So they're angles that lie on the line?
Mm-hmm. Angles that form a straight line. So like, that's a linear pair right there. If we called that angle A and that angle B. Vertical angles, remember vertical angles, draw your little picture. Anytime you make two lines intersect, you form two pairs of vertical angles. If we called that A and B, A would be congruent to B. If we called that C and D, C would be congruent to D. All right. Any questions? I just want to point out on the bottom, there's some pictures of complementary and supplementary angles. Notice the angles do not have to be joined. 1 and 2, here they make complementary, but they also make complementary like this. Same thing with supplementary. Okay. All right, one last term. Yes, Jeremiah? Yep, that's the last one. One last term, adjacent angle. Was that your question? Okay. Next page, on the next page, they show you some adjacent angles. Adjacent angles are just angles that lie next to you. They're like neighbors. Okay? Like the person who if you live in a neighborhood, the person that lives adjacent to you is your neighbor. You share a property line. Adjacent angles share a side. Okay? All right. Now let me pause. How many of you? All right. Any questions about adjacent angles? By the way, these are non-adjacent. So like none of you are my neighbors, so we're non-adjacent neighbors. Okay? I mean, you're not my adjacent neighbor. You're just, forget it. All right. Moving on. I want you guys to try some problems here. Give this one a go. 1, 2, 3, and 4. You put them on your note page. Remember, just so we're not confused, these are the monitoring progresses out of the textbook, not out of your workbook. You can't find these in your workbook. Okay? So for those of you who are like, man, I can't see those really well out there, then you should move forward. Ooh, we got open seat right there. You guys have that like prime seat. These are the ones we charge the most money for. Bill you later. How many have an answer for one of them? 2 of them? 3 of them? 4 of them? How many got stuck? you. I just how many got number 1 right? How do you know you got it right? Oh, just confident. It's okay to say I'm confident. I just know I got it right. Okay, name a pair of complementary angles and a pair of supplementary angles and a pair of adjacent angles. So give me 2 that are complementary. They add up to 90. Maddie? FGK and angle what? Angle GKL. Everyone agree? GKL and F41 and 49, those are complementary. Good job. Okay. Are those adjacent? Not adjacent. Okay. How about a pair of supplementary? Sam? LKG. And which one? KGH. Okay. So 131 and 49. Everyone agree? Where are my supplementary ones? Yes, Danica? Yeah, these two right here. 41 degrees and 131 degrees. They share that one side. Okay, how many got all 3 of those? How many missed the adjacent? Anyone miss the supplementary one? Complementary? Okay. All right. Number 2, are FGH and LKG adjacent? Who says yes? Who says no? Got to pick a side, man. It's like rooting for a football team. You got to pick a team even if you don't like football. You're watching a game. Your friends are making you watch. You have to pick a team. It makes it more interesting. Okay. So our FGH, let's go FGH. No, I'm sorry, FGH and LKG. So is this big angle right here and this angle right here, are those adjacent? Who says yes? Who says no? Those are not adjacent. No. They do not have a common side. Okay? They do not. Maddie? 131 and 49? Right here and here? Yeah, isn't that what we said? LKG and KGH. Yeah, these are supplementary. Yep, these two. The ones we traced were these were our adjacent angles. Okay? Our FGK and FGH, are those adjacent angles? So is this angle right here adjacent to this angle right here? Okay, the answer is, who says yes? Who says no? Who says I'm not sure? Even if you said yes or no. Okay, the answer is no. Okay, this angle right here is not adjacent to this angle right here. It's part of that angle, right? So if it's part of it, it's not adjacent to. All right. So really quick, going back to our picture of adjacent angles. Adjacent angles have a common vertex and a common side. Okay? They share a common vertex and a common side, but have no interior points, no common interior points. So this one would have these points interior that are common. All right. Angle, who got number 3 right? How many are guessing? I might have it right. Okay. Angle 1 is complement of 2. Okay, so that's not up here anymore. So we have angle 1 and angle 2 are complement. What's that mean? Good. The measure of angle 1 plus the measure of angle 2 equals 90. Okay? If angle 2 is 5 degrees, what is angle 1? Yes?
85 degrees.
85 degrees. Angle 1 has to be 85. It has to add up to 90. Isaac, did you get it right? Well done, dude. Did you get number 4 right? Angle 3 and angle 4 are supplements. That means measure of angle 3 plus measure of angle 4 add up to 180. If angle 3 is 1/48, what is angle 4? 32. Good job. Okay. Right. How many got them? Okay. So some vocab kind of messed this up a bit. All right. Any questions there? Give number 5 a go. Work with your cool guy groups. You guys get about uno minutes. Maybe uno and a half. I don't know how to say that in Spanish. All right. Anyone have their work that I can put up here? You're not done yet? How many are showing your work? That's good. Well, can someone tell me what I need to do? Abdul.
Okay, so first of all, complementary angles are equal to 90 degrees, so the division is 4x.
Okay, 4x minus 2. So you said they're 90, right?
Yeah.
Okay. Plus what? Okay, 9x plus 1. Is that what you set up? All right. So combine like terms, how many x's do we have? 13 x's. How many units do we have? Units means how many numbers without variables? Negative 1 equals 90. 13x equals? 91. So x is? 7. All right. Do we find it? We done? Tell your neighbor what's wrong with that answer. Do we have to plug it in? 4 times 7 minus 2, or 28 minus 2 is 26. 26 degrees. And we could actually check right now, right? We know 26 plus what is 90? 64. Okay, so this better equals 64. 9 times 7 is 63, plus 1 is 64. Good. So our angle measures 26 and 64. Well done. All right, everyone rate themselves 1 to 5. Okay, so pretty easy, right? All right, let's see if we can, while I'm handing out your assignments, if you guys can figure out those there. Number 6, do any of the numbered angles form a linear pair? Okay, now kind of a really good question that came up. It's like Carson said, well, 3 of them make a line, but by definition, a linear pair is 2. So not any 2 form a linear pair, but it's good to recognize, hey, 3 angles can make a line. But in this case, no. No for a linear pair. Which angles are vertical? There are a lot of vertical angles, right? So, for instance, like 6 and 3. Those are vertical. Okay, or 2 and 5. Another pair of vertical? 1 and 4. Those are all vertical. Vertical angles are congruent. Number 7, or do we have them all? Yep. Number 7, the measure of the angle is twice the measure of its complement. Find the measure of each. Dude. Measure of an angle, what are we going to call that angle? What do you call something when you don't know? X. So the measure of x is twice the measure of its complement. So is it the same as its complement? No, it's twice its complement. Okay, so x plus, how do you write twice? 2x? Why don't you guys talk about that real quick? Come on, see if we can remember our algebra skills here. Anyone know the answer to it? Carla? Huh? So 60 and 30? Okay. So does that fulfill it? This one's twice its complement? Okay, so how would we write that? No, everyone's waiting for me to just give you the answer. I'm not willing to just give you the answer. Yeah?
1/2 x.
So 1/2 x. Okay. So you're saying half x.
No, x plus.
Oh, x plus 1/2 x equals 90. Okay. So is x the bigger or the smaller? The bigger. Okay. What's another way we could write it? Yeah? Okay, so you could go that route, or you could say 2x plus 1x equals 90. In this case, you're finding the smaller, right? So in this one, you're finding the bigger. This one, you're finding the smaller. Okay, here you're doing 1.5 x, so 3/2 x equals 90, which x would equal 60. That would give you the bigger, and then you'd have to subtract. Okay, and here you're equaling 3x equals 90, or x equals 30. That gives you the smaller. Okay. All right, we're about out of time. Hey, you guys have your assignment. That's due tomorrow. Okay.